Let's talk about naming alkenes. Just a reminder that the end of the name here is got to do with the functional group of a double bond, and that the alk has got to do with the chain length. And in QCAA, we go up to 10 carbons. Okay, let's start with simple naming, and we're going to add some stereochemistry in here as well. Let's do a double bond, and remember, around this double bond you can either have the two alkyl chains on the same side, which is cis, or the configuration Z, or we can have a situation where they're across from each other, which is trans, or the configuration E. So let's just start with one where that doesn't make any difference because the double bond's on the end. First of all, as normal, we name the number of carbons. We start with the functional group. That's the highest priority. In this case, there's only one. It's alkene, and that has to be on the lowest numbering. So we do that. And we name the chain length. This is a 6-carbon chain, so it's going to be hex. It's going to be some form of ene, but the double bond's at position 1. And we don't normally have to put where it is at double 1, so it's really just hexene. There's no stereochemistry to worry about because there is nothing either trans or cis to this double bond here. Let's go to page 2. Let's have a practice. Let's do a double bond and put some groups around it, and let's number this one. Let's first of all notice that this configuration is a trans configuration where the substituents come up across from each other, each side of the double bond. Let's number the chain such that the double bond is on the lowest numbering. So it's in this direction written in yellow, rather in this direction that's written in red, which is incorrect. Okay, so now we can name it. It's got 5 carbons, so it's a pentene. The double bond is at position 2 on the lowest numbering, so it's a pent-2ene, and in QCAA you would say that's trans pent-2ene, although the correct name is pent-2ene, showing the stereochemistry across that double bond. The reason it's done this way is that if there's more complex molecules, for example, let's draw in something like this, where we've got more than one double bond and more than one stereochemistry, then this could be numbered in this way, in which case this is a nonene. What type of nonene is it? Well, at position 2 you have a cis stereochemistry, so it's Z. At position 4 you have a trans stereochemistry, so it's E. At position 6 you have a trans stereochemistry, that it's E, and it's a triene because it's got more than one double bond. It's got 3 double bonds there. You won't have to name dienes or trienes or multi-enes, but it's just showing you why it's important in the real world to put this within the name, because what do we call it otherwise? Cis, trans, starting from the beginning. Let's go to page 3. In this example, we'll do a cis alkene. Let's put in the double bond. Let's put it cis around that double bond so the other chains are coming off each side on the same side. Let's put in another carbon there, and let's name this one. Let's number it where the alkene, start of the alkene falls at the lowest number, so at position 2. Again, it's a pent, and it's going to be a pent-2ene. And if we wanted to put cis in correctly, we would put the Z in there, or you would just go pent-2ene, and notice that it's cis is the other way of doing it. Okay, let's see if you can do one, and then pause up this while you're looking at what's going on. Let's put it in a bit longer. Okay, just make that a little bit shorter there. Okay. So just give you a chance now to see if you can name this one. So pause this and then come back to it. Okay, let's put the numbering in. Again, we're starting from the left because the double bond will fall on position 4 rather than if you did it from the other side, it would fall on position 5, so that's incorrect. Let's go back to this name. It's going to have 8 carbons, so it's an octene. The double bond starts at position 3, so it's oct3ene. We can see that this configuration like this is a cross, so trans. And if you're naming it correctly, you would put oct3ene at that point. Let's go to page 4. Let's put in a more complex molecule that's got some substituents on it. Let's put something like this down and see what we'd do with this one. Okay, let's try a few numbering systems. Because it's an alkene, we have to have the alkene functional group at the lowest numbering, and it has to be part of the main chain. So we have to put the numbering here. When we get here, we've got a choice to go to the methyl or the ethyl, so we go up here. It's a 7-carbon chain, so it's a het. All right. The double bond's at position 2, so it's a het2ene. It happens to be trans, so I'm just going to put that stereochemistry there, but of course you would just know that as a trans het2ene. And now we have to put the substituents in here. First of all, position 3, there's an ethyl, and at position 5, there's 2 methyls. We put it alphabetically. Then it's 3-ethyl, dash between the number and the word, and it's 5,5-dimethyl. So it would be 3-ethyl dash 5,5 dash dimethyl hept dash 2-ene if done correctly.